I'm still Jeff Valenti. I've narrowed the talk to coordinated parallels because I have 15 minutes and I can't figure out how to go backwards. There we go. Okay, so you can follow along if you want, except now your APT versions have all these complicated things you were working on, but in principle you could follow along. I also wanted to illustrate, there's a lot of stuff you can fill out. There's X's at the top to encourage you. When I want to try something in APT, I'm pretty good at ignoring X's, and I'm going to show you how I ignore X's, and then you can do it too. So you do have to make a new document, a new JWST proposal, and then this appears over here. You've all seen this now. And so then it's an optional step to make targets. Sometimes I don't even bother making a target, but it's pretty straightforward. You just say fix target. You type in your favorite one. I like LMC because it's 3 letters and it's always visible all throughout the year. You search for it, and it comes back with these coordinates for you, and then you push the select object as target. You can do everything I just said faster than I said it. I mean, once you know what to do, it's just super fast. So now the targets has turned into, it doesn't have an X anymore, and it's a thing you could open up and see about the targets. You have to go down to the observations, which you've now done. You create a new observation folder, which you've done, and then this appears. So that's all good. We're going to get to the parallels shortly, but again, it's really fast to just do this. You're on your way already. You don't have to worry about getting rid of the X that says what's the, I don't know, maybe it's just me, but it's like I specify my target and then there's an X and I feel like I have to go put a category in for it. But after the 12th time or so, you just like, nobody's going to know if I don't put the category in now, right? I can do it later. So I'm liberating you now. Just fill out the parts that are necessary to get the answer, right? And then later go back and fill in the others. Okay, so you got to pick an instrument, which you know, pick Miri, you got to pick a template, which is coming up on the next slide. So I think I went to, what did I do here? 16, 17, 18. Haven't picked a template. Right. So, oh, I see the sequence here. So template. So I'm going to pick Miri imaging, one of the 4. And then you'll notice if you compare the left 19, the one with the 19 and the one with the 21, that having picked Miri imaging, a new box appeared in the form, in the template area, above the template area in APT, because Miri imaging is one of the things that can have coordinated parallels. So the box appeared, you check the box. You guys with me? Once you check the box, you can, the drop-down menu becomes active, and there's 2 choices. You can do Miri near-cam imaging, which is one of the combinations of coordinated parallels, or you can do Miri imaging with nearest wide-field slitless spectroscopy, which is another one. And in fact, I put here for you all of the ones that you could discover. It turns out there's currently one template for each of the instruments that allows coordinated parallels, and they have 1 to 3 combinations that are enabled. You've seen this before in a different format. This is what it looks like in APT, which is, of course, where you, if it's not in APT, it's not going to happen. So you see that the highlighted ones on the top are just the swapped ones, right? You can have Miri B prime with near cam parallel, which means when you specify your target, like, M83 or whatever, Miri will be centered on it, and near cam will be over here somewhere. If you instead were over in near cam land, then near cam would be centered on M83, and Miri would be off somewhere else. Okay. There's a couple 3 other symmetric combinations. The ones that are not symmetric are the middle one on near cam plus nearest imaging. The converse is not enabled at this time. And the bottom left, near spec multi-object spectrograph with near cam imaging. The converse is not defined because it makes no sense to image a big field and then hope that the shutters are on something over in parallel. That's just not going to work, right? Okay, good. So it's a good idea. Well, so I'm going to take a little diversion and say you don't have to pick a target all the time to do things. You can get some interesting results if you don't. But since I bothered to specify the target up above, simple enough. You just choose your target, done, right? So no problem there. You see this Visitt splitting thing? This was the question I said I would answer. You guys have seen this in here. This says for this target, a new visit will occur if your cumulative dithering from where you started, your pointings, exceeds 55 arc seconds. That didn't happen here, so I have one visit. So let me explain that again on this slide. So an observation is one instance of a template. You go into APT, you select a template, you start filling things out. That's one instance of a template. We call that an observation. I underline the word because it's a key word for us. A visit is something that actually goes up to the telescope. There's a guide star acquisition, and then there's like exposures and maybe some dithers and stuff if they're not too big. So observations, it turns out, wind up forming one or more visits. APT will split an observation into multiple visits if the cumulative dithers exceed whatever the splitting distance is. And the splitting distance is given in this plot, which you can try to find in JDocs. It's a good scavenger hunt. I actually had trouble finding it, but I know where it is now. We're going to make it easier to find. On the y-axis is the splitting distance. It ranges between 30 arc seconds and 80 arc seconds. And you saw on the previous slide that in my case, the LMC, it was 55 arc seconds, which is, well, it's 55 arc seconds. The x-axis is galactic latitude. So what's going on here? What's the logic underneath this? We don't actually check, because it's hard for us to check, whether a guide star would work for your particular case would work for all your dither points. Instead, we did some statistical analysis and we said, in the galactic plane where there's a ton of guide stars, we're pretty confident that you can go 80 arc seconds and use a guide star. In other words, you're pretty likely to be able to find a guide star near the middle of the guider that can move around. But as you get above the galactic plane, the density of guide stars goes down, and so we have to be more conservative. And in the worst case galactic latitude band, we're only reasonably confident with 30 arc seconds. So that's what all that Visitt splitting stuff was. It's not really important to parallels, but since I had the floor, I thought I would explain it. Back to parallels. Okay, so this is what the larger view looked like before I checked the coordinated parallels box. And I want to highlight down on the bottom the template parameters for Miri imaging, which is what I selected for the template. That's the only tab that appears there. And then there's some other ones, mosaics and special requirements, which are there. But once I checked the box, two of them appeared down here. Two tabs appeared, right, in addition to the mosaics and the special requirements and stuff. So now there's Miri imaging plus NIRCam imaging. And you, of course, can imagine that if you picked a different combination, different tabs would appear in different orders. Right? Okay, so next up, we fill out the Miri imaging parameters pretty much as usual. You have to select a subarray and then add a dither type. And so, I selected full up there and point number 29. But the dither type is a little interesting here because the imagers have different pixel scales and different PSF sizes and are slightly rotated with respect to one another. The dither patterns that were best for Miri are not the best compromise for when you're doing both at once, right? So you do have all the native Miri template dither possibilities, but there's a list of them that continues, and I highlighted the slider bar because the first three are 2.4, 3.4 point dither patterns tailored for the Miri PSF size at 7.7 microns. And there's a 9 point, and then the 2, 3, 4, 9 repeats at different wavelengths. So it's a little bit complicated, but otherwise you would have to do a lot of math in your head that's really hard to figure out what to do about your dither patterns. So we've cooked some up for you. Okay, so I selected that, and I even defined a second one because I decided I'm going to do two different filters in this, and so I selected the 4-point at 12.8 microns as well as another dither pattern. Then you have to go down and add your exposure specifications, so I'm doing that now. These are the same as usual. I'm showing you the menu. You pick the filter. You say how many groups you want per integration. We're all pretty comfortable with that now. What's this dither thing over here? I thought we already specified the dither. If you haven't done the Miri templates yet, you're just selecting which of the two dither specifications up above you want to be used for this exposure with this filter. And in this case, it's the 7.7 micron filter. I want to use the 7.7 micron customized dither pattern. And then, of course, you do it again, but select dither pattern number 2 for when I do the exposure at 12.8 microns. All right. And then I have at the top 39. So we've been filling out the Miri template, which is almost like the Miri template is normally when you're not doing coordinated parallels, except that there were some custom additional dither options. Now we're going to go to a second tab, which is NearCam, right? And this is simpler than it usually is. I'm not showing you what it usually is, but it's a lot simpler. We're going to pick whether we want to use one module or all the modules, and whether we want to do full frame or subarray, and then we're going to add the exposure specifications for NearCam, which will happen in parallel with Miri. So there's I want both modules, all modules of NearCam. I want the full detectors, not subarrays, and I started filling in the exposure specifications for NearCam. There's the short wavelength side, and the long wavelength side filters, and the readout pattern that you want, how many groups per integration for NearCam, how many integrations you want. But you see the dithers are now grayed out because we're doing coordinated parallels, and it's the prime instrument that the system is going to pay attention to as far as dithers go. NearCam doesn't get to drive the dithers at all. The parallel instrument doesn't get to drive the dithers at all. So this all looks good on top, and there's actually no red X's right here in the vicinity. But if you go look on the tree editor on the side, there is still an X on this observation, and the error that pops up says, for those that can't see it in the back, each template in a coordinated parallel observation must have the same number of exposure specifications. Each template, so that means Miri and NearCam templates, have to have the same number of exposure specifications. That's these rows here, and there's one row here for NearCam, but there were 2 rows here for Miri. Remember, I had 2 different Miri exposure specifications. So this error is telling me I either have to get rid of a Miri one or add another NearCam one. Well, I want to add another NearCam one. That's great. Let's do it. So I added another one here. And now red X's appeared. The absence of a red X before is a debatable feature of the thing, but these are now red X's, and if I'll read this for you because you may not be able to see it, the parallel exposure specification has a duration of 300 seconds that is longer than the 70 seconds of the prime, and then there's a similar error message for the other one. So I made my NearCam exposures longer than my parallel exposures are longer than the primes, and that's against the rules. You have to make your parallels fit inside your primes, okay? So there's various ways you could solve this. The way I'm going to do here is I'm going to go back to Miri and say, well, I actually do want to go this long, and so I'm going to get the Miri exposure times longer by increasing the number of integrations. I didn't change anything else here. Previously, I had 1 integration per exposure, and I just increased them to 8 and 6 in order to get the Miri exposures long enough to contain the NearCam ones. And to get back to this, of course, I clicked on the Miri imaging tab template thing. So now if you look, having done all that, now there's no X's on the observation. We still have those X's up above that I ignored. I still have to go back and say what type of target it is and who the PI is and so forth. The next steps would be to go look at the visit planner and make sure it schedules well, and to view in Aladdin where you can see the drawings of both the prime and the parallel field apertures on the image of the sky. Please remember, in general, not just with coordinated parallels, that Aladdin is showing you, if you haven't put any orient constraints, it's showing you one possible orientation, right? And so you have to be, not just believe that that's the only, that you will be scheduled at that orientation. That's it.
Setting of an instrument while the other instrument is observing?
Is it possible to change the setting of an instrument while the other one is observing? We don't allow mechanism motions while another instrument is taking an exposure. It is possible to move mechanisms in parallel on the two instruments. But then there's a wait afterward. Then there's a synchronization point where whoever finishes first has to wait. And I'm actually glad you mentioned that, because I meant to say that currently, I mean, the new version of APT that's coming out probably will be missing the extra overheads for waiting for parallels. So, but there's nothing you can do about that, so just ignore it for now. And when the call for proposals come out, if you're doing parallels, read to see if there's anything special you have to do about overheads.
Okay, if we have no more questions, then we thank Jeff again.